From the Navier-Stokes equation, we will again derive a form of exact solution which is known as uh, Poiseuille flow, right? You have to check the spelling. It's actually flow through a pipe, right? This direction we take as x, and this direction we take as y. Okay. Now we will be using polar coordinates, which is a bit difficult to write, but this z is almost the same, right? So uh, if we take a very long pipe which is axisymmetric, so from axisymmetry we get these terms as 0. Okay, there is no radial flow, so ur terms are 0, only ux or only u is there, right? U theta is also 0. So from this we can find that P is a function of x only, and uh, U is a function of R. So only this, and we can say that a kind of this term will remain, but this will be in polar coordinate. So we will have 1 by rho dp by dx is equals to 1 by r d of dr r d ur, sorry, not ur but u by, in this direction I'm calling the velocity as ur, right? Now again, since u is a function of r only and p is a function of x only, so for these two terms to be equal, it has to be equal to some constant. Now we will integrate dy dr r du by dr is equals to minus 1 by rho dp by dx. This is r, so r du by dr is equals to r square by 2. So this cancels out, so du by dr, sorry, plus c1 by r u is equals to 1 by rho I think I've done a mistake because a mu term will also be there. So this will be 1 by mu, not 1 by rho, right? 1 by mu dp by dx r square by 4 plus c1 ln r plus c2. Again, we will have to use boundary condition. This would be the profile. At r equals to 0, u exists. For this to happen, c1 has to be 0, right? We will find c2 at r equals to r, where u equals to 0, right? So c2 is equals to minus 1 by mu dp by dx r square by 4. So u is equals to minus 1 by mu dp by dx 4 1 minus r square by capital R square, right? Okay, so this is the Poiseuille equation. Now u max is at r equals to 0, so u max equals to minus 1 by 4 mu dp by dx, right? Now you have to find u average. U average is this is a thin strip. This is the pipe. This is a thin strip, right? Of thickness dr. So area, the flow rate would be integration 0 to r 2 pi r to dr. This is the area, and this flow would be, if I'm considering some constant, right? It's the a. I think I've missed a r square term over here. R square minus r square, right? This would be divided by pi r square. So u average becomes here will also be an r square, I'm sorry, right? So this term becomes 1 by pi r square 2 pi a to r square r minus r cube dr. Pi and pi cancels out. 2a by r square integration of, or we will integrate it this time, r square by 2 minus r to the power of 4 by 4 r 0. This is 1 by 4, right? So this becomes a by 2, right? This r square actually this is a without the r square, because I am multiplying this with r square, right? So this a into r square. Okay, so a into r square is nothing but u max. So u average is equals to 1 by 2 u max. So u average is equals to minus 1 by 8 mu dp by dx r square, right? So we can write u is equals to twice into u average one minus r square by r square, by substituting this over here, right? Okay, now we will find, this is a pipe, right? This is a cross section of a pipe, and there is a shear stress tau. So tau is mu du by dy. Okay, so this is the direction of u and this is the direction of y, but we have du by dr. We will take du by dr. R is in this direction, so we will be taking a negative sign over here. So tau is equals to mu, differentiating this, du by dr is equals to twice u average minus 2 r by r square. Mu, this minus, as I told already, gets cancelled. U average, I'm writing it like this, r, but this r is at the wall, so r is small r equals to capital R divided by r square, right? So tau is equals to 4 mu u average by r, right? We know friction factor is tau by half rho u average square. This will give us 4 mu u average divided by r, 8, 2 goes up, rho u average square But in fluid mechanics, by convention, we take we consider d as the characteristic length. So F is 16 by rho u bar d by nu. This is the Reynolds number. So friction factor is known as the Fanning's Fixer factor is 16 by R E D. Right. Moving forward, we will use this equation. Right. U average is equals to minus 1 by 8 mu delta P by L. This is the pressure drop over a length L. R square. This can be written as head drop rho g hf. This is head due to frictional losses. Head loss due to friction. So U bar is equals to, actually this would be actually negative. So 1 by 8 mu rho g hf by L R square. U can be written as Q by pi R square. So HF, or I'll write this square. So HF is Q by pi R square L mu 8 rho g r to the power of 4. I think this is right. Again we will convert this into D. So this is 128 Q mu L by pi d to the power of 4 rho g. This is Hagen. Again check the spelling. Poiseuille. Hagen-Poiseuille's equation. This is Hague. I'm not sure if this is the correct spelling. Uh, okay, so we will be using this equation once again. So HF L into L by D V square by 2G if we try to break this down in this form, we'll have HF should be d by l. Hold on. uh, uh, u bar is equals to 1 by 32 mu rho g h f by l d square. So hf to d by l u square by 2g. I'll stop it here. I'll continue this part in the next video. Right? This would give another friction factor, which is 64 by RE, which is the Darcy's friction factor. Right? CF is 4 times F. This is the relation. Right? We'll get back to this.